Hi everyone, thanks for joining us here on the Reactor. My name is Olivier Bloch, and we'll be talking about IoT today. It's the third episode of a series, which is about time to simplify IoT. The gist of the series of short sessions is to revise how we talk about IoT. We have been talking about the fact that IoT is complex, it's complicated, and we want to simplify it, or it needs to be simplified for our customers, as Microsoft, as well as partners and so on, to be able to implement IoT or to integrate IoT into their solutions. I'm a principal community PM in the Azure IoT team. My role is to connect the community of developers working on IoT projects at large with the engineering teams. And when I say connect, it's bi-directional, which means that we want to share information, but I also want to hear from you. You should feel free to comment so that we can interact. I'll try and keep track of the questions if you have any during today's presentation. I don't like to call them presentation. I like to call them interactions. So if possible, say hi and eventually ask your questions when they come up. Once again, I'll try and keep track. So as I was saying, this is a series of several episodes. And the way I wanted to break it out, and I wanted to go with a 4-part series, was to approach the various areas that we sometimes, and everyone claims, are complex or complicated in IoT, and want to approach them with a fresh eye to kind of simplify at least the way we're talking about it, and then demonstrating that at the end of the day, it's not rocket science. In that first episode, we talked about, or I talked about, the simple ways to prototype a solution. Lots of IoT projects stall at the prototyping stage, at the proof of concept stage, whether because the value of IoT integration or addition into a solution has not been validated, has not been demonstrated, or because people were not able to implement the solution the way they wanted or the way they envisioned it. And it's super important to be able to go straight to the point, validate hypotheses and theories, and validate the value add that IoT brings into your solution. And so that was the first episode. I'm going to have some links for you later on to catch up on that. The second one was about integrating IoT devices into solutions, how to get them connected, how to get them, how to interact with them from an application, how to integrate them into the application, into a process, into an operation. And there was an interesting talk, lots of reactions talking about no code for IoT devices and so forth. The third episode was supposed to be last week. It's today. And I'm sorry we missed last week. It's been pretty hot over here in the Pacific Northwest, and I was just not ready. I couldn't work for a couple of days because the room I'm in right now is not climatized. There's no AC in the house, and it was pretty hot. So, but don't feel sorry for me, and no reason to. I'm here, and next week we're going to have the next episode. Today we'll talk about making the edge intelligent. We'll talk about what is the edge. And I'll try and demonstrate that at the end of the day, it's not that hard to make that edge intelligent. Hey, Praveen, I see you're saying hi. Nice to have you here. And in the next episode, we'll talk about the I in IoT, the internet part, but it's not the topic for today. Today, let's talk about making the edge intelligent. So what's the edge again, right? That's a term that's been used and overused, I would say. You hear it a lot. So here I'm not talking about Microsoft Edge, the browser in Windows. It's a fantastic browser, but that's not the topic. What we call the edge in the context of IoT is the following. So this is IoT, right? This is a very high-level diagram that I've been using here and there. The concepts of IoT or the definition of IoT, at least to me, and the way I want to talk about it with you today, is this notion of connecting devices, things, to be able to extract insights from their data and monitor them remotely, control them remotely, and integrate that wealth of data of intelligence that these devices can bring into solutions to enhance these solutions. We talked about examples of all of that. So in that context, you have the notion of the cloud with the services that are used and overused up there. And then you have notion of devices, and we'll talk about the gateways, different types of devices, and so on. The edge is everything that is not the cloud, basically everything which is at the edge of your solution. And as we'll see, the edge is more than just the tiny sensor down there. And it includes a bunch of things that are higher level. And we'll talk about that. I didn't include in the edge the business application part of the story here. That person to the right that has the reports. It's to me for illustrating the business app part of the application. I'm not including that in a definition of the edge, even though you could argue that they're using devices and interacting with the solution. But for now, I'm really talking about the operational part, the connectivity part, and the what's happening on premises, in a factory, in a building, and so on. So that's the edge. So we're all clear. Why would you want to make the edge intelligent? And this is a very interesting question, because I think I like this idea of a pendulum, this image of a pendulum, where when it comes to IoT and embedded, we went through phases in the last 20 years, I'd say. And when I started my career, it was all about getting these devices out there smart. We talked about smart devices. They were not really connected yet. They had to have some intelligence run on them for them to be capable. And you'll see there's lots of that we'll cover today in making microcontrollers intelligent, in making them able to interact with their environment and to act on it, or to act based on that environment set of data that they receive. But there's been then this notion of smart connected devices. The idea was to go beyond just having devices being able to do something with software, but being able to share that data with broader applications, having the devices send the telemetry for bigger systems to be able to analyze the data. At the time, it was not really realistic running machine learning on tiny microcontrollers. As a matter of fact, it's becoming realistic now only. But we'll talk about that a bit more in the talk today. And in that trend of connecting the devices, we started thinking about the cloud, the backend, as being the intelligent part, and the things as being the sensors, just sharing the data, with that idea of saying, hey, we're going to send all the data to the cloud, and we're going to have infinite resources, infinite storage, infinite compute, right? That's what the cloud is about at the end of the day, to make our systems intelligent. Well, we're coming back from it, where we are looking at ways to make our system more distributed, that intelligence to not be only on the device side of things, or on the edge side of things, or only on the cloud side of things. We need to distribute the intelligence. We need, and we have to. And here is why, right? Because you would wonder what kind of scenarios we're talking about where you need to have some sort of intelligence at the edge, some sort of self behavior, self-conscious type of thing. I'm not talking about Big Brother or something like that yet, but I'm talking about systems that are able to manage data locally. That's one of the main scenarios for what's going on at the edge in terms of becoming intelligent. The need for keeping data and your secrets safe. Whether you're running a factory with very expensive IP, something you invested in terms of software, in terms of algorithms to enhance a production, to create a specific product certain way, and also isolate your critical resources. You don't want to be subject to an attack, a ransomware attack, for your system to be blocked and your production lines to be blocked for like costing millions of dollars or whatnot, because your system is being corrupted because it was connected to the internet. What you want is to be able to have some number of things happen on premises, happen in your facility, data to not go out. That's also valid in government application, or for data sovereignty. Some countries have laws preventing you from sending data abroad or offshore or somewhere else. You cannot do that. You have to keep the data of your customers, of your employees in your own premises. And this is one of the scenarios that making edge intelligent, will help sort out, will help facilitate. Another one is related to connectivity caveats. So when your cruise ship or your mobile vehicle is connected to the internet because it has, Wi-Fi, it has cellular, all good. When things are getting a little bit less easy, I would say, when your cruise ship is connected through a satellite connection because it's offshore, and satellite connection is very expensive, or is your delivery truck going in a tunnel, it's not connected anymore. You need to have some level of monitoring, control, self-awareness happening on premises, on the device, in the building, because connectivity is not a given. It's something that you should expect to be flaky, to not be consistent, and sometimes to be very expensive. So you have to have a way to dispatch your solution, distribute the intelligent blocks all the way down to the edge. Another one is latency. In that, pendulum story of having devices being more and more smart, and then having the devices being connected for the cloud to come to the rescue and being able to analyze things with very rich machine learning algorithms and so on, you have a problem, which is the back and forth to the cloud is something that can eventually be time consuming. You have a network in between, you have gateways, and so you have an unknown, which is how long will it take for a piece of data to go up to the cloud, being analyzed, and a command sent back to the device. A simple scenario, if you have a robot arm that has a safety zone around it, you need to have a set of sensors that are able to analyze, detect anomalies, detect that something is wrong based on a certain set of rules to prevent someone from getting hurt, for example. So you need to have local extraction of insights and an implementation of an action. You need to take action based on data that is locally produced, and you need to be able to analyze the data down there. Once again, at the edge, as close as possible to where the sensor data is being produced. And I'm not saying on the robot arm in that case, but I'm just saying as close as possible. And this is an important aspect of making the edge intelligent, is that you will also need to think about where that intelligence sits on your premises, because you have different types of devices down there. The edge is populated with a bunch of things, and I'll try and deconstruct that a little, but think of it as a set of, from smaller to bigger entities, devices, machines, groups of machines, clusters that build up, depending on your needs, your solution, or part of your solution. Let me take some examples here. Here I have some examples of a retail shop, of a factory floor, of a cruise ship, of mobile vehicles, of a government building, of a smart building. Hey, hi, Bruce. Thanks for saying hi. Welcome today to the Simplifying IoT third episode. And whoever else is joining, you can catch up on demand after the show. So you have all these scenarios, all these different places, all these different facilities. And in there, you have microcontrollers, tiny devices, sorry for that, tiny devices that are capturing the data from the sensors, that are controlling tiny equipment, or part of equipment. They're part of a robot arm. They're part of a satellite. They're part of the engine of your cruise ship. They're part of all the electronics that are in your car. They are in your security cameras. They are in your point of sale. They are in your printers, in your HVAC system, like in this smart building illustrated here. So this is a kind of devices that are programmable, but have limited resources. They run on batteries, or they have, for cost reasons, they have to be built with a limited bill of material. And so they can do what they can do. And you need to tune them based on what your scenarios are. And once again, as we'll see, on how much you can run on them and how you can connect them to a broader system to distribute that intelligence that you want to develop and you want to have running at the edge. Another type of devices, I call them gateways. Think of it as beefier devices, bigger devices. They're more in the class of devices that can run a full-blown operating system, while microcontrollers will run a real-time system or a tiny OS or sometimes software directly on the silicon. Here, gateways are things that allow you to bring in services on top of an OS, a reach OS, once again, like Linux or Windows. And you can use these, I call them gateway, illustrate them as a little thing that connects other things. As a matter of fact, very often they are using these tiny sensors as the source of data. So you have a motion sensor, for example, that has a little Wi-Fi chip on it that shares its data with that gateway. That gateway is a beefier device that can do some level of analytics. And you can manage these devices with common tools like you're used to when you're managing an IT infrastructure filled with Windows and Linux machines. So these gateways are these a bit bigger type of machines, can still be considered as devices, as IoT devices, but are also contributing to extending that intelligence at the edge. Then you have another category of device, and it's a bit blurry here, which is what that I would call the servers. Server class of machines are things that might not be as movable, as transportable as a gateway. They are, though, very similar to gateways. They do run a full-blown OS, could be a server version of Windows or Linux, and they are on premises. They have bigger storage capability, bigger compute capabilities as well, and they're used for running locally, much more intense processing, much more intense insight extraction, and so forth. Last but not least, there is the category of things that we call private cloud. When you grow from one server to a rack of server, then you have it. That's your first private cloud, because you can start running services on these. You can have hosted services as well. And then it actually spans from your on-made, mini data center in the form of a rack of servers to things that, Amazon, Microsoft, Google offer, a cloud on premises, your own very version of Azure, for example, in your premises. And it also can take different shapes. Think of things like Azure Stack. Azure Stack offers, with a hub in particular, that kind of mini Azure on premises, where you can run the same services you have in the cloud, public cloud offering, running in your premises, running in that rack of servers of yours, and allowing you to implement scenarios as rich as the ones you would with a cloud, but everything locally. Data stays in your factory floor, stays in your government building, can afford, like for the cruise ship example, to not be connected all the time and to be autonomous. So these are kind of devices that you would expect to be at the cloud. And for all of them, you're going to have different ways of implementing that intelligence at the edge. And it might feel daunting and hard, because you have these different types of devices running different types of OSs or non-OSs, and you will want to have tools and technologies that will help you abstract the complexity that are underneath of connectivity, of security, of communication, for you to think about the value add, which is how do you compose your intelligence by distributing it. Here is my little algorithm that extracts data from sensor. Here is my reacher machine learning algorithm that will detect anomalies in there. And here is my database of local database of customers, where I can do the inference on images to detect, a movement, to detect the behavior and do something about it, keeping data private, keeping everything on premises. I feel thirsty today, not sure why exactly, but it's going to be lots of water, I guess. Hydration is key, I was told. So hydrate yourself as well, where we are here. Grab a cup of coffee or something. So these are the type of devices and that you would expect to find at the edge. So now the question is, I know that you want to have your edge being more intelligent. You see all these types of devices that are out there. Now let's talk about how you can make them intelligent. How can you bring that intelligence to the edge? And I will start with the most obvious. Devices I'm not even talking about the private clouds. Private clouds type of things, they already come with that intelligence. They already come with all the machine learning goodness and the storage and so on. You tune them based on your requirements and needs, but I would say this is no rocket science. This is, this is software running on servers, and not the topic of today. So I'm going to skip that one and go directly to the other, I would say, obvious place where you want to bring very rich intelligence. As you'll notice, I'm taking it backwards. Usually we start with the tinier devices. How do we make these tiny things intelligent? And we go all the way up the stack. I'm starting from the obvious ones that we don't need to talk about. And then we'll look at the gateway servers type of devices. Things are running at Windows or Linux. These things will allow you to run package managers, will allow you to leverage technologies that have been developed for the web, that have been developed for enterprise and business applications, things like Docker, things like Node packages, things like Java libraries, anything that allows you to package a functionality, sometimes with an OS around it, or as part of an OS around it, allowing you to compose, allowing you to distribute. These technologies are usable on these kind of IoT devices. You can take your Linux-based gateway and run Docker containers on it, which means you can create a service that implements some form of algorithm, maybe based on a machine learning training, and implement that intelligence at the edge. And we'll see that in a second. Do you need to know about how the OS works? Do you need to know about how a technology like Docker works? Do you need to know about other packaging technologies? I would say, yes, you do to a certain extent. But there are tools out there that allow you to benefit from these infrastructures, from these technologies, without having to think about it too much. And there's one technology in the realm of Azure called Azure IoT Edge. I will not go into details here, but what I will do is I will use a device to show you what can be done for distributing some level of intelligence on a device that runs a build of Linux and that leverages Azure IoT Edge, which is no more than a way of running containers and orchestrating containers on this class of device. And with no further ado, what I'm going to do is I'm going to switch to that demo in order for you to see what's going on. So I need to move that window over here, and I need to switch to my screen and myself. Well, actually, let me show you this little device first here. So this device is called Azure Percept. It's a dev kit. It comes along with a full AI suite of tools and services bound to cognitive services on Azure, bound to machine learning for vision or speech, and more in the future. It allows you to very rapidly, and as you'll see with no code, implement some form of intelligence and easily distribute that onto devices that are at the edge. All of that managed from the comfort of your seat and from the cloud, basically. Let me do something with that so I can keep track of your questions. Actually, good track. Praveen is asking a question about how gateway and edge differ. Is edge a gateway with high processing power for running an ML model? Can they coexist? So, Praveen, I was describing edge. The way I'm talking about edge, it's anything that is not the cloud, right? Now, if you're asking about Azure IoT Edge as a technology in particular, IoT Edge is a technology that powers gateways types of devices or servers types of devices. So a gateway is going to be something that is on your premises, very often has leaf devices, enables connectivity for these devices to a broader system, right? If these devices are on a closed network or on a particular local bus, like CAN, like Modbus, like BACnet, that are specific to a vertical, to an industry, then a gateway allows these devices to share their data and to be monitored and controlled from out there. As a matter of fact, because these gateways are running or supporting a bigger OS, bigger CPU, more memory, you can start thinking of running something on there, not just having them behave as a pass-through. And we are seeing more and more customers looking into how can it take advantage of having some processing power down there on premises that until now was just merely used to secure a locked down network or just pass through data. And so now you can start thinking about how you can bring that intelligence. And what I'm going to show you with Azure Percept and with that dev kit is that you can start doing that pretty easily. So let me switch to this view here and let me bring up the Azure portal. Because I already have a device that is connected behind me, I went through the Azure Percept Studio tool here. I'm not here to make tons of publicity around Azure Percept itself. What I would like is, oops, sorry, I'm messing up with my Windows right now. Oh, hold on. Someone break my configuration, I think. I have Windows 11 installed, and maybe I should not do that before a presentation, right? Okay, so let me do this here and that here. Okay, and I'm going to fix that on my side. This is real life, you know, and I don't want to be in a place where things will just mess up. So let me fix that. Give me a second for fixing my screen, so it will become weird. That second screen should be a composition like that, and get out of here. I'm using Fancy Zones. And this is a nice power toy tool that allows you to define areas on your screens as the recipient for a window. Anyways, so Azure Percept, the concept is to make AI at the edge easier. So let's assume I have this gateway type of devices. It's running Linux. On it, I have a package manager, a container manager called Azure IoT Edge. It's almost anecdotal here. What I want to focus on is what do you need to do to create intelligence and deploy that and run it on such a device. And assuming that the plumbing is being taken care of, there is a cloud gateway that allows that device to be connected and controlled remotely from the cloud and from Azure Percept Studio. This is in the case of Azure, it says Azure IoT Hub, which is under the hood, and I'm able to control that. So Anuj actually is responding, I think, to Praveen as well. I think Gateway can talk to the internet cloud, and Edge may or may not directly connect to the cloud. So Edge may connect low-range protocols like Bluetooth. But I think, Anuj, that's a good way of trying to differentiate Gateway and Edge. I personally think gateways are part of the edge. They are one of the types of devices that are at the edge. And yes, gateways will be here to sometimes translate a protocol, pass through data to be used when they're used as a firewall. Edge is a composition of sensors, gateways, servers, and what you see in today's demo using Azure IoT Edge, which is once again maybe confusing because we're using that name here. Think of it as a runtime for enhancing your gateways and servers types of devices. It allows you to bring these containers down to these devices for you to run Reacher type of software that is managed from a remote location that is distributed onto these devices. Gateways, servers, this kind of devices. I hope that makes sense. I'm happy to debate more about all of that. I think it's very interesting. So here in Percept Studio, I have a device that has been connected using the plumbing we described in the previous 2 sessions. And now what I want to do is allow for it to run something. So the device itself has a camera and has microphone sensors. And it's firstly meant to be a developer kit for you to create proof of concepts. So if I want to eventually create a prototype, I want to run one of our demos of tutorials, like one of the basic ones, one of the ones we're already there. So if I want to try, for example, one of the vision models, what I'll be able to do from the comfort of Azure Percept Studio when it loads will be to pick among different samples and to send it down to my device. I think the device is actually already running something while it's loading. What I'm going to do is that. So this is my device. As you can see here, it is analyzing its surroundings, and it has a general object detection algorithm running. And the way it's been composed, I'll show you in a second, is that you have a module, a container that has been generated using the cloud training tools to recognize objects. You can use third-party ones, open source technology, and you can also train your own model. I will show you some of that in a minute. And so the idea here is that it's been packaged, it's been deployed, and now it's running down there. There's a module that captures the image from the camera, and then it's ingested into that object recognition algorithm that runs on that device, and then it's giving a result. As a matter of fact, it will send its telemetry up to the cloud to say, I detected that and this and that. And so before I change the model, actually, let me go to my device here. Let me pick it up. And let me show you. You see the video frame, right? That's me waving. You can see my guest room behind me. If I click on live telemetry, what you're going to see in here, let me just do screen and me so you can see our telemetry. It's detected a TV monitor, a laptop. If I bring back the Percept live stream, you can see the laptop of this guy here, and you see the percentage of certainty. There's a person, that's me, right? And so the device has been doing the work, and it's sending up to the cloud the result. So you're actually doing something interesting here. That device, by having that intelligence running down there, can deliver anonymized data about the fact there's someone in front of the camera passing by, and eventually reach your thing. Hey, you have the phone in hand, or I don't know, whatever scenario you can think of. But then your application that received that information doesn't need to have the actual image, doesn't need to have data about the customer itself, coming from that device directly. It can act on data that's been pre-baked for it, and doesn't need to collect all the data. You save on bandwidth, you preserve privacy for the customers in that case, if you're in a retail store or something, and you keep your data, critical data or sensitive data, private data on premises. It doesn't leave the device. As a matter of fact, once the data has been computed, you don't need to keep the images, right? You don't need to keep anything. You just do the processing, extract the insights, boom, done, right? So for now, it's detecting anything. Let's go back to our studio. Let's try and see if we can deploy a sample vision module. As I was telling you, this device is connected to the cloud, to Azure Percept Studio, using some plumbing. And here what I want to do is I want to change that to a vehicle detection algorithm. So someone has been creating a model that detects vehicles on a stream of images, right? And right now you see it's detecting an object. What I'm going to do is I'm going to click deploy to device. Because the device is connected, I can tell it, hey, now you're going to run a different module here. It's going to be a different types of intelligence, and I'm going to ask you to detect vehicles, right? Moving vehicles. So it's loading the model. It's basically loading a new model from the cloud and bringing that model down to the device. And once the model will have been downloaded and run on that device, you'll see that it will no longer detect me as a person or whatnot. What it will be detecting is cars. And here I have a video of cars, because I don't have a car or a window on the street here. So what I'm going to do is I'm going to, oops, sorry, my bad. I don't know how to use a tablet. That's very sad. Okay. And so here you have a video of cars, of moving cars. And if I bring it closer, you'll see that it's able to detect cars on that video. So the device that was originally detecting things and people and whatnot is now detecting cars. And it took me a click of a button to deploy a model that's been pre-baked for me. If you get a chance to put your hands on an Azure Percept, or if you're curious about Vision AI, there's like a couple of projects out there I really recommend you go check out. You can, with Azure Percept, create your own vision model. You can ingest a set of videos from the device itself, and then you can use cognitive services on Azure to train these to train a model to recognize objects. And eventually I could walk you through the beginning of that. There are some very interesting videos and tutorials that are out there. We have some good ones from some of our MVPs as well on the tech community blog, on the msiotblog.com site. So I really invite you to go and check it out down there. And you'll see that that it's pretty straightforward. The tools are there. The way you can train models, you don't have to be a data scientist to do that. So you can really do that pretty easily when it comes to vision, when it comes to speech. These are the things that are provided to you as tools. Let me actually go to speech. That's an interesting one. We very often just show things that are related to the vision part of things. But let me bring up something around speech. So there also are a couple of samples. What I want to show you is how you can very easily, in that case, deploy a new intelligence. So the thing is detecting cars again? I don't know. That's weird. Let me just kill that thing here and just have the screen in me for now. So what you can do is create a digital assistant. That's one of the samples that we have here. And that's very interesting because there are some complexity in detecting a keyword, recognizing a keyword locally. And you know that because you're using your digital assistant. I won't say the names because there are some around me and they might react, but you're used to that. There's a keyword that triggers the voice recognition. Device starts paying attention when that keyword is pronounced. And here, I want to show you how I can create a new one, how I can bring up and deploy very easily on that device a piece of intelligence that will be able to recognize a new keyword. So, for example, I'm going to create a new keyword here. And that's leveraging cognitive services from Azure up there. And I will try something like hello world, and we'll see if that works. And I'm picking a speech resource, which is the cognitive service instance that is behind, and that will compute for me, or that would train the model for me to allow for that device to recognize based on the audio sensors specific keywords. So I'm creating that one. Hopefully, it won't take the 30 minutes they're saying it will. And here, what's going on is that the cognitive service is training a model based on the entry here, which is hello world. I determined, or I indicated it was in English, and that we're able to do that. Other questions in the meantime down there, Praveen, can we deploy custom models, such as detecting if a person or not only? Yes, you can deploy any kind of model. You can train your own model, and then you can test it, deploy it, and eventually go to production as well. Once again, this is a broad topic we need to double click on. We could, and there's tons of videos here. I want to keep it to the concepts and principles. You have an infrastructure that allows these devices to be connected, and from the comfort of the cloud, you'll be able to compose your intelligence in the form of containers in the case of Azure IoT Edge, and deploy them in a control way on a set of devices for them to do what you want them to do. In a retail store, the camera will have to detect people to identify traffic. Is that aisle crowded or not? Is that one not even like walk through? Is that cash register totally packed with people? Can you trigger alerts based on that, and so forth? So people counting is a good example. Security and safety is another good example of this kind of use. And yes, you need different types of algorithms applied to video in different kinds of scenarios that we're showing, like the car one. Anuj was saying, cool, I had used Intel DK300 series gateway that way, so I guess my thought biases come from that. Oh yeah, you were on the discussion about the gateways versus edge, and yep, okay, we're on the same page. Okay, so I deployed that. Let me check where, I'm not stalling, I promise, where that speech API is. It's actually training it. So let me change, actually, let me deploy another one that's been already trained. I'm gonna assign that keyword to my device here. It has a module running that is about keyword detection. And so I'm gonna deploy that to that device by just a click of a button here. Now what I want to do is say a command. I want to tell that device to do something. And so I have a set of commands that I can work on and control here. I have, for example, created already something that is going to be dispatched on that device, but I'll do that while we are double clicking on that. So let me save that, dispatch to the device, but let me show you what that looks like. Okay, this is doing its thing. Okay, let's try and click on this guy here. So what that is, let me bring the window over here so you can see it. It's loading. It's going into the Speech Studio, which is the cognitive service interface for creating your custom commands, custom keywords, and so on. Okay, for some reason it's pretty slow over here. Might be overloading with OBS on my side. Okay, so here you see set of commands. There's a fallback one. I created one called ambient pink. And in order to train in Speech Studio with no code, an algorithm that will be able to identify a sentence and take action, what I needed to do was to enter a set of sentences that I would expect a user to pronounce, to say. Set lights to pink, set ambient lights to pink, set lights to pink, set the ambient lights to pink. It can go on and on. The more you have, the better. And then you train that model and you publish it. Same thing for ambient white, same thing for ambient off. And I was able to create these from Speech Studio without having to write a line of code for creating a very smart digital assistant, right? So now you can be like in Iron Man, you can have your own Jarvis and control your environment without having to code all of that. The speech APIs are here for you. Speech Studio will help you do that. And this is an illustration of how things are evolving to make that creation of an intelligence for the edge easier and smarter. Let's see all of that in action here. If I bring this guy here, and I think I said something, let's see. Hey, computer, set the lights to pink. Hopefully it's going to get it. Boom. You see lights here? They went to pink. Because over here, something I didn't show you, my bad, is that in my speech API or Studio is able to determine the sentences, but then there are rules that I can apply. And when that sentence has been recognized, then what I'm asking is for an endpoint to be called, a web endpoint to be called. And that web endpoint is no more than a REST API that has been calling, they've been setting up. It's called ambient pink. And that when there's success, it will send back a message. When there's failure, it will send back a message as well. So you can create your all digital assistant that way. That web endpoint that I've been setting up for pink is just as you can see here. And if this is the net REST API, it's a simple post, pretty straightforward, nothing rocket scientist-y here, pretty straightforward. Praveen was asking, hey, as it is a dev kit, can we use it for production? So we have a very interesting IoT show episode with Dan Rosenstein about the Azure Percept design choices. And he was explaining that the modules that are on the Azure Percept dev kit actually have been developed with that in mind. You not only can build your proof of concept with the dev kit that is here, with the main unit, with the microphone array, and with the camera, but these are actually SOMs. There are things that you can buy from Microsoft as element, as SOMs, and you can then add them to your own design for your own needs and your own device. So you can definitely go to production with the various components. As a matter of fact, they're exposed here physically because you can use them in different kind of scenarios in production. So I want to skip gear here. I want to go back to the slides for a second, and then I want to switch to microcontrollers. We have 15 more minutes, and what I would like to do is, I'm talking too much, is to talk about the microcontrollers. We talked about the servers, the gateways type of devices, the running Windows and Linux. So at the end of the day, if you think about it, it's pretty straightforward and easy, I would say, to deploy stuff on them in terms of intelligence, because at the end of the day, it's no different than a PC, right? Or a server, right? So pretty straightforward and easy. Let me talk about how you can do that on microcontrollers. Let me go back to my screen and right? This is here. And I'll bring my favorite friend here, which is Screen and IPCam. This is my little M5 Go dev kit that I used on the first couple shows for showing how you can do things without code on microcontrollers. That's interesting for demonstrating points like the one I'm making today. So let me bring up the UI flow tool, which is gone from my list of apps. Okay, indulge me one sec here. I'm going to bring that right now. Okay, we'll go there. That's going to work. And I'm going to go to flow. Pretty straightforward. This is a UI interface for those who didn't see the first episodes. It allows me to remotely program a microcontroller without using code. It's using something called Blocky. So here I have a device that I want to display something on. I have a circle I'm going to bring it on here. And that circle, I want it to turn red, for example, or let's say green, because I think the red will not be visible here. And I'm going to put it like big one here. Okay. And that's white. Okay. And I'm going to center that, straightforward. I have a motion sensor has been connected to that device. And that motion sensor here, I want to act on when something happens. Let me bring in a loop. I'm going to add a little timer, because you always want to have things happen with a timer in a loop. And when I detect some motion, I'm going to do some logic. If I detect motion in that loop, what I'm going to do is we say the circle should be set to, let's say, green. Okay. And I will also, for the sake of having some light here, I will set the RGB light, which are a set of LEDs on the side, to the same color, green. As you can see, it's all off here, so it should be fine. And then if there's no motion, I'm going to go back to white for the circle, and I'm going to turn off the RGB bar, right, with 0, 0, 0. Pretty straightforward. Let me try and see if I can connect to my device and deploy this piece of code. And here's the point I'm making. I can create some level of intelligence of my microcontroller using very simple code, and I can deploy it very easily. And here I have the first level of intelligence on my device. When something happens, like movement in front of it, the dot turned green, the light turned green. When there's nothing happening, it turns back to white. If I move again in front of it, it turns to green. That's a very basic intelligence, right? But that's intelligence still. So yeah, that's the first level. The second level is something that you want to be a bit more evolved, I would say. Something that runs machine learning at the edge on microcontrollers. And for that, what I want to bring up here is a technology as an example called Edge Impulse. So let me bring it over here. And Windows 11 just blew my shortcuts. I'm not sure why. Let me bring that guy here. So Edge Impulse is a very nice technology. I invite you to go check out. It allows that simplifies the way you are creating machine learning for little devices such as this little guy here, which is a wire terminal, and other types of microcontrollers. So the principles is to allow you for capturing data in a web browser tool to create what they call an impulse, which is a set of blocks that will help you clean up the data, and then bring up some classifiers, some algorithms that you will configure and tune in order to create a neural network. And that neural network in concept is something that I'm fairly sure I don't really understand, but I didn't need to understand it really well to do what I did with this little device, which has a motion sensor in it. And what I did is very easily with that tool, I was able to capture motion data. So I went on and captured like 3 motions. Actually, I went on and captured the wave motion. I captured the circle one. And as a matter of fact, this is, and then there's the idle one, right? Stop nothing. And what I did was go to that panel here. I connected my device because it has a firmware for edge impulse that allows capturing the data. Otherwise, you have all the tools for those types of devices that allow you to connect over USB and forward the data from a device. I need to turn it on in order to capture the data. So the device would have been connected. I would have hit like create a sample, and then I captured this kind of thing. So these are the 3 data coming from the accelerometer, and it did allow me to capture like 5 seconds of a movement. And when I was doing a circle, you could see that, and like that, you could see that the data captured has been moving on the 3 axes. When I was captured, and I did that like about 10 times. I went to the wave. The wave was just lateral, so you can see that the z-axis is not moving as much as the other ones. And here I'm messing up with the pink. That's okay. Let me see if I can bring some light to remove that ugly thing here. Let's see if it's making it worse or better. Kind of better. No big deal. You see my trick of having devices showing up here. So Bruce is asking, what is that software edge impulse? That's a set of services and tools that are leveraging TensorFlow APIs in order to simplify how you build the model and how you deploy that on device. And here what I'm demonstrating, and sorry for if I didn't do a proper introduction of edge impulse, it's an example of a technology that will simplify the way you are creating machine learning algorithms for microcontrollers, because it will simplify the creation of the models, but also optimize the binaries that it generates for specific hardware to make the algorithm as little as possible on that device to run intelligence, the best way. So here I train all of that, and then I create an impulse, and then that's the way you would go about it. Once again, I'm not sure I understand still, neural networks really well. My understanding is very basic. Is the fact that you have at different layers of what they call neuron or features, things that are in relationship with each other. All layers are in relationship with a lower layer. And you want to go from a set of data all the way down to, in my case, 3 answers, 3 outputs, actually 4. One is I detected a circle, one is I detected a wave, one the device is idle, and another one we'll see is there's an anomaly has been detected. And so you come with like a bunch of data, and then you define different levels in your neural network, and each of them have a lower number of neurons, right? You trickle it down. And there is a way of determining, how this reduction is, what each of these neurons are really about, and that's what the neural network block is about. That is based on these various layers. We'll see that, and that when you start the training will allow you to, or on its own, determine the weight of each of the relationships between the neurons on each level. So each level, each neuron is related to all the other one, but each of these relationships has a different weight after the training, because it will look at the different path, and depending on what lens, because you've been scoring that entry data, it will be able to determine the best path for the data as close as possible to the ones that you had at the beginning. So it's something that you'll see intuitively. Okay, I get it. And then you look closer and you just, still hard. But here with the edge impulse, it becomes pretty straightforward. So here I have my time series data. I brought in a level of processing that allows to clean up the data, extract from XYZ in that case some more interesting information. Here with that type of block, I extracted a DSP filter. I applied a DSP filter, or it applied. It extract also the frequency domain for each of the XYZ. You would have a different frequency for XYZ depending on how you're moving, right? Same thing for the spectral power. What kind of power of intensity on each of the signals do you get? So here you see for the circles, I have a specific shape, and all the circles numbers will show a result that is kind of similar. Then I switch to wave, and this is different. This is different here. You see not the same frequency domain, not the same heights in the peaks here, and so forth. So here with that first level of filtering, I would say, I'm actually extracting from the raw data of the accelerometer data that will be easier for a classifier to work with, right? And so you have different types of processing blocks in Edge Impulse you can use. My classifier then is for me to determine the layers of this neural network, and for each of the paths then to have the weight on the connections determined after training. Here I already created that. That's a very nice sample. I'm starting with 33 features. That's 33 captures that I had at the beginning, transformed with the spectral transformer block. It was actually able to extract 33 features. The first layer is 20 neurons, the second one is 10, and I'm finishing with 3 only, right? Idle, circle, and wave, right? And here, after training, you can see that my model is pretty good, and it's actually visualizing here in 3D based on the entry features, the 3 dimensions here, the clusters. Here you see all the circles. Down here you see all the waves, and in the corner here, idle. And so that shows me that when I'm going to input a new set of data, it will use the classifier, the algorithm, to put them in the right place on that diagram virtually, right? And will determine which group it's part of. And the proximity of that group will be the percentage of accuracy on that. And here you can see my device has been already working that. Anomaly detection. Beyond having this classifier classify, this data, what I can do as well is I can bring in. Let me remove that for a second. I can bring in and add anomaly detection, because if I have only 3 clusters of results, but I have something that is not in there, right? Imagine there's a motion I don't know about. Then I can have Edge Impulse send me a score for an anomaly. Hey, I've never heard about this. So chances are it's an anomaly, and that's also a result for me. And so I'm able to add this in the math for having an extra result that is the anomaly part. You can, with the Edge Impulse, do a live classification. That means you can actually run the test from the Edge Impulse backend, sending data from the sensor, which is the device itself, and Edge Impulse will allow you to see the result on that. So you can test your model directly from the comfort of the cloud without having to deploy anything or whatnot. Once you've done all the training, all the testing, and you're happy and you fine-tune your model, then you can create the binaries that will be used on the device, whether it's a C++ library, whether it's optimized for some hardware acceleration like TensorRT from NVIDIA. You can also have WebAssembly if you want as an output, or Arduino library. And eventually you can go all the way down to building an actual firmware for a set of the boards that are supported by default. Exporting for Arduino is what I did here in my case. And what it did, it created a C++ library that was able to just compile it in the Arduino IDE or in Visual Studio Code to classify a set of data coming from my accelerometer. And so here you see in the code in loop, it's pretty straightforward. I had to include one library because the export from Edge Impulse created a library for me. So I just included a header here, and the actual algorithm for recognizing the gesture has been deployed for me, has been created for me. And here I'm able to start the UI because I want to display something on the screen, and then get the data from the motion sensors. Let me go back down there to loop. Here I'm capturing the acceleration data, and I'm creating a buffer, which is a similar size as the ones that I've been capturing for my training. And then I'm cleaning things up a little with that API from the library, and I'm just running the classifier that will score the probability that the movement is a wave, is a circle, is idle, or if I have an anomaly. And as a matter of fact, now if I run the thing, what I'll be able to see eventually, let me try and connect the serial monitor here. Okay, so here I have, you see idle 0.99, so that's 99% chance it's idle. If I bring the device, you can see this well. So I have the little guy here. I'm going to shake it, and I should see the score for the wave go way up. And let me see, wave, oh, it's all the way down there. So the wave here, you can see went up 99%. If I do the circle, the device will show circle, and you'll see the scores. You can find it here. Circle is 99 point something percent, and then goes back to idle. And now if I do something that is unknown, let me do that, which is an anomaly, right? It says anomaly because, yeah, it doesn't know what it is. And it has an anomaly score that is higher. And in that case, I will not score it as idle because it's not idle. It's an actual movement. So that's an illustration of what to expect with Edge Impulse, and that simplifies your life when it comes to developing for microcontrollers and bringing intelligence down there. So before I let you go, because we are already running out of time, and I'm on top of the hour, and sorry for keeping you around. If you want to ask a question, like, don't hesitate. I want to bring you to some of the call to actions here. You can watch this episode again on demand. You can reach out to me on Twitter at oblock. You can rewatch the full series, the 3 first episodes on demand, and then the 4th one that will be next week, where we'll talk about the internet that is in IoT. And I also invite you, if you want to double click into IoT this month, look into aka.ms/JulyIoT. This is where you'll have plenty of news about what's going on in the IoT realm. Our cloud advocates and MVPs and so on have been putting tons of very nice content for you during the months of July to learn more about IoT. So I definitely invite you to go check it out and have fun there. So it was pretty fast. I hope you enjoyed it. Bringing the intelligence to the edge is not so hard. I did go super fast through Edge Impulse, through Azure Percept, surfed over lots of the concepts, but my intent here was really to show you that you have tools, you have means. You don't need to be a data scientist or a mathematician to implement algorithm that can run at the edge. And sometimes as well, it's not just about ML. It can be about basic software. You saw the few lines of non-code on my device that was able to detect emotion and take action. Leverage libraries, leverage existing technologies, compose your software, bring the intelligence at the edge, distribute your solutions intelligence. And well, I see you next time. Hope you enjoyed this talk today. Have a good one. Bye-bye.